All right, so we are looking at the 10 questions for exercise 10.1 with some simple calculations here. And let's take a look. Question number 1 asks, what's the molar mass of a single mole of carbon? Well, if we look over here at our little chart, we see that carbon is 12 grams per mole. So very simply, let's see if we can get this to start typing. Very simply, we have 12 grams per mole. And that's all that the first question was. Very simple there. All right, next question. What's the molar mass of 1 mole of carbon tetrachloride? So we've got 1 atom of carbon, and then we have 4 atoms of chlorine. So that's going to give us 1 times 12 plus 4. And looking over at our chart, we see that chlorine's 35 grams per mole, 4 times 35. And when we do that math, we're going to have 140 plus 12 plus 12 equaling 152 grams per mole for carbon tetrachloride. All right, our next question is, what's the molar mass of 1.5 moles of sodium? Going over to the chart here, we see that sodium is 23 grams per mole. So the math for that is 1.5 times 23 grams per mole. And when we do that math, we have, what do we have? We're going to have 23 plus, what's 1/2 of 23? 11.5. 11.5. And so that is going to equal 34.5 grams per mole. All right, what's the molar mass of 0.25 moles of sodium hydroxide? And first thing we need to figure out is what 1 mole is. So we have 1 atom sodium, and that atom is, sodium is 23 grams per mole. We have 1 atom of oxygen. Oxygen at, we look over to the chart, 16 grams per mole. And then we have 1, and let's see, let's just tidy this up a little bit. We need a plus in there. And let's put a plus in here for grins. Then we have 1 atom of hydrogen at 1 gram per mole. So finally, that gives us 23 plus 16 plus 1 for a total of, what's that look like? 40 grams per mole. Excellent. Okay, so now we have, oh, but the question was, and that's going to be, let's see, hang on for a second. Go to number, go down here for a minute. All right, so our question in total here was, we only have 0.25 moles. All right, so 0.25 times 40 is going to give us a final answer of 10 grams. 10 grams. Okay, now how many atoms are in 10 moles? That's a brand new game all together. And we know that 1 mole of anything is equal to Avogadro's number, 6.02 times 10. And we use a caret symbol. Where's the caret symbol? I'm out of practice. 10 to the 23rd atoms. So we would multiply that by 10, and our answer is going to be still 6.02, but we're going to raise the factor by 1 order of 10. So we've got 10 to the 24th atoms in 10 moles. All right, did that make sense? We would have had 60.2, but we don't like that times 10 to the 23rd. However, we don't like having this decimal. Over here, so we move that over 1. And had to raise that exponent by 1. All right. Now, let's see. How many atoms are there in 1/2 a mole of C6H12O6? A little bit of glucose there. And so we would have 0.5 times 6.02 times 10 to the 23rd. Our exponent's going to stay the same, and we're going to wind up with 3.01 times 10 to the 23rd. All right. How many atoms are there in 6 grams of carbon? All right, so 6 grams, so 1 mole is equal to 6.02 times 10 to the 23rd atoms. And we need to figure out how many moles of carbon we have. We have 6 grams of carbon, and we're going to divide that by the number of grams per mole. And that is going to be, that's going to give us 0.5 moles. 0.5 moles in 6 grams. Well, if we look up above at the answer, we had 1/2 a mole that we calculated to 3.01 times 10 to the 23rd. So once again, we have 3.01 times 10 to the 23rd. All right, very good. And we'll do one more before we raise the screen here to capture. Now, so we have 90 grams of C6H12O6. We need to calculate, first of all, how many moles that represents. So the first thing we have to do is calculate 1 mole of C6H12O6. So carbon is 6 times 12. We have only 6, yes, 6 times 12. Plus our hydrogen, we have 12 of those, and they are 1 gram apiece. And then finally oxygen, we have 6 oxygens, and each oxygen, looking over the table, is 16 grams each. So that's going to be equal to 72 plus 12 plus 6 times 16, 332, so that's 96 grams for the oxygen component, and that is all going to be equal to 180 grams per mole. For that sugar, we have 90 grams. I give you 90 grams. We divide that by the 180 grams per mole. And that's going to be equal to, once again, 0.5 moles which we know to be, let's move this molar mass table, which we know to be, let's go back to this one, back here, which we know to be, we've seen it in the other calculations. We have half a mole. So how many atoms? Once again, it's 3.01 times 10 to the 23rd atoms in 1/2 a mole. And so again, that's a three different ways to look at kind of the same thing, half of a mole and the number of atoms based on Avogadro's number. All right, let's pull this screen up a little bit so we can finish up. And let's see, looks like I ran out of, yeah, I did run out of Blackboard. Anyway, back to here. Let's do number 9, and then we'll make some adjustments. Number 9. So here I have 1.5 times 10 to the 23rd molecules of oxygen. And so real quickly, 1.5, let's just figure out how many moles we have. 1.5 over, I'll do this more complete, times 10 to the 23rd divided by 6.02 times 10 to the 23rd. And so that gives us 0.25 moles. All right, now 1 mole of oxygen, one atom, if we look over here, is of oxygen is 16 grams per mole, but it's diatomic. So we have 2 of them together. So 1 mole of O2, atmospheric O2, is going to be 16 plus 16 equals to 32 grams per mole. But I only have, what did we say? 0.25 moles, right? So we're going to multiply that times 0.25 moles, and that's going to give us a total of 8 grams of O2. Good. Now, here we have run out of space, and let's see how we can do that. All right, just a second. Let's go to the background. The image. Now, got to get out of text. Image size. Let's make the height 14, give them a little more space. We want to constrain the proportions though. Original width was 20. All right, that did the whole thing. All right, let's see then. Well, since we've mangled that up, let's do it real quick over here. All right, so we've got 18.06 divided by 6.02. So that gives us 3 moles that we're dealing with. Each mole is 2 times 14 grams, which is equal to 28 grams per mole of nitrogen. And then we're going to multiply that times 3. So very sneakily in the corner over here, 3 times 28, 60 plus 24, 84 grams is our final answer. So there you go. There you have the answers, the methodologies behind 10.1, those 10 questions. And that is all for the day.